Hi there, welcome to Sequence. We are going to be talking about a list that follows a pattern. The patterns that you can have when you're dealing with a list of numbers is arithmetic. That is an addition rule. You will be adding the same number time and time and time and time again. Or you could have geometric, which is where you are multiplying by the same number over and over and over and over. Geometric is always multiplication. Arithmetic is always addition. Here's our arithmetic rule. If you distribute this d to the n, you actually end up subtracting your d value, the number you're adding from your a. I don't like to use that, but that is a formula. Some people choose to use that. I like to think of it as a dn plus c, where d is the number you are adding in your list. C is the 0th term, not the first term in your list, but you need to take one step backwards. I will show you exactly what I'm talking about in a few moments. N is your term number, and a sub n is the value of that term number. So if n was 1, your first term, well, what would be the value of that first term? Okay, coming over here into geometric, similar type stuff. N is the term number that you have. A sub n is the value of that term. A sub 1 will be the first term in that list, and R is the multiplier, the number you are multiplying by. So one of the best ways to deal with this is to actually look at it in action. First, let's deal with some arithmetic. So imagine that was my list right there. I could be asked for the nth term. That is synonymous with writing the rule. Hey, can we express this list as a rule so we could find any number in that list? Well, what are we adding? So 5 to 7 is a plus 2, 7 to 9 is plus 2, 9 to 11 is a plus 2. 2 is your d value. Then we need our c. Well, c, as you see here, is the 0th term. So if we were thinking about this, as we should, 5 would be the first term. That is the second, third, and the fourth term right there. Okay, well, if you want the 0th term, you need to jump back one step. So if I'm adding 2 in this direction, well, I need to go 2 back, so c would be 3. Now we can go right ahead and we can write our rule. A sub n equals 2n plus 3. That rule expresses this list. So if we were to plug in 1 for the term number, 2 times 1 is 2 plus 3 is 5, the value of that. If we plug in a 2, 4 plus 3 is 7, the value of that term. We could find any term in this list. Some people express this as t of n, and those two things are synonymous with each other. So let's run through a couple more examples here. (30, 27, 24, 21, ... Okay, let's write the rule, find the nth term for this. Well, what I'm adding, my d value, it is minus 3, minus 3, minus 3. So the number I'm adding would be negative 3. D is a negative 3 value. And then C is my 0th term, so I need to take one step back to find my C value there. How about 33? Does that follow the rule? Well, subtract 3 there. Yes, so my C value would be 33. So A sub n equals negative 3n plus 33. There's our rule that expresses this list. How about 1, 5, 9, 13, ... Write the rule to express this. Well, I can see that we are adding 4 every single time here, so my d value, the number I'm adding, will be 4. C is one step back, the 0th term. So let's see, what can I do to get there? Well, I'm going to need to add 4 to that, so how about a negative 3? So negative 3 plus 4 plus 4 plus 4, so that holds true. C equals negative 3. My rule, A sub n equals 4n minus 3. That expresses that list, and we could find any term you would like in that list. Now let's take a look at some geometric here. So sliding back up there, you have all that arithmetic. On one side, we're going to be dealing with the geometric. So how about we look at 1, 2, 4, 8. There's our list. Well, I'm looking at that list and I'm seeing that if I take this, I multiply by 2, multiply by 2, multiply by 2. So my multiplier, my R value right there in the parentheses, will be 2. I also need a sub 1. Well, that is the first term, so the first term in this list would be 1. It is different from what we were doing over here with my arithmetic. A is simply the first term, where C here in the arithmetic we had to go one step back to find the 0 term. Please don't confuse those two. So now having my A sub 1 and my R, I can now write my rule. A sub n equals A, my first term, my multiplier raised to the n minus 1. Knowing what we know about lists, that is the first term, second, third, and my fourth. So if I were to plug in a value of 1 into my rule, I should get out 1 for my first term. So 1 minus 1 is 0. Anything to the 0 power is 1. 1 times 1 is indeed 1. If I plug in 2, I should get out 2 for the value of that term. So 2 minus 1 is 1. 2 to the first is 2. 2 times 1 is indeed 2. So plugging in 3. 3 minus 1 is 2. 2 squared is 4. 4 times 1 is 4. And the same thing with 8. It works. There is our rule that expresses it. Let's look at 40, 20, 10. Okay, so I'm seeing that we are multiplying here. A lot of people are like, well, you know what, it kind of looks like we're dividing, and you're right, but here dealing with sequence, we can only express this as a multiplication problem. So if you are seeing that you are dividing by 2, you're correct, but that is also multiplication by 1/2. And my first term is 40. So A sub n equals my first term, A sub 1, times my multiplier to the n minus 1. There is our rule. If you're ever looking at a geometric sequence and you cannot figure out the rule, pick a term in this list. Doesn't really matter, just don't use the first one. Okay, so let's say I choose 20. Put that on top and take the one right before it, put it down below. And then reduce that, and you can see that that does become 1/2, and it should work with all of them. So if I took 10, and I put the one before it underneath, 20, that will indeed reduce to 1/2, and that would be your multiplier. Should work for every single one of them if you are multiplying by the same value. How about 60, negative 30, 15, negative 15 halves? We are multiplying by the same number every time. Well, you can see that it is getting chopped in half, so that means we are actually multiplying by 1/2. But you can also see that the signs are changing. So we must be multiplying by a negative 1/2. A sub 1, my first term is 60. A sub n equals 60, my first term, times my multiplier to the n minus 1. There you go, you have your list. Please understand that the list is pretty much the same thing as the rule. The rule will generate any number in the list. The list will lead you to the rule. These are relatively interchangeable. They mean and represent the same things. Same thing here. There's my list and there's my rule. My rule will give me my list, and my list can give me my rule, back and forth, so on and so forth. Have a great day. Appreciate it.